Hello and welcome to a new video. Today's video is the first video in about 3 or 4 videos discussing and dedicated to discuss control valves. In a process, we may need to regulate the flow rate, we need to control the pressure, we need to control level or temperature. And the way we do this is by restricting the flow in a pipe. In other process, we may need to stop or allow the flow in a pipe or to isolate a section of the plant. And so this is the difference between an on-off valve, which is only can allow and stop flow in a pipe, and the control valve, which can restrict the flow to a certain degree. You can see here in a process, we have a control valve, and this is our pipe and our control valve. Control valves consist of certain parts. The first one is the body and the actuator, and then we add more accessories to it. About the first section, which is the body, we can have a globe valve, ball valve, semi-ball, butterfly, a gate valve. Now, how you open and close the valve is through the actuator, which could be pneumatic, hydraulic, or electric. So let's start with a globe valve. A globe valve is a plug which is closed against a seat. So it would allow the flow from the inlet to the outlet through the distance between the plug and the seat, which is shown here. The seat can have many shapes and the plug can have a different shapes. The different shapes of the plug will allow us to vary the distance between the seat and the plug in a different ratios when the valve is fully open or 50% or less or more. The seat and the plug can have different forms, but if you look at this, we can see here the different shape will give us a different areas when it moves from the seat. The plug, when it moves from the seat, will show a different areas. So if you move 5%, the area may increase by 20% or less or more. That is based on the shape of our plug. The flow could be from top to bottom or from bottom to top. This is a different type of globe valve. You have a cage or a cylinder with opening on the sides, and the shape of the opening will vary depending on the characteristics of our valve. And this we call it the cage. And now the flow rate goes from the bottom through the hole out, or from around the cage to the inlet of the cage to out of the valve. This is a different type of valve. We call it a gate valve. You can see this is one gate valve, which is huge valve. This is during testing the valve. And as you can see here, the plug is a sheet of stainless steel is running between the parts of the body. And as you can see here, it extends outside the body. And this is our actuator. This is a different type called ball valve. As you can see, the ball here has a small notch in it, and the stem goes into the notch to rotate it, to close it 50% or 0% or 100% or anything in between. So now you can see that this valve rotates to open and close the valve. The gate valve, we have a sliding stem, goes up and down, and the globe valve also was sliding stem. These are different types of semi-bore or cam. This is from Mason-Nealon, the rest from Fisher or different manufacturers. You can see here this is a part of a segment of a ball with some notches in it, which will change the characteristic of the valve. Butterfly valve, as you can see, it rotates a disc, rotates inside the body of the valve, and it can have different shapes. The different shapes can give you different characteristic again. Now you can see here, this is the center of our disc. It's exactly in the center of our disc is the axis. Now, if you move the center of the axis here, one shift to the side, one shift to down, so we have more than offsets. The offsets will allow us when the valve moves about 2-3% or even 5%, it will leave the seat and there will be no friction between the disc and the seat. This will give your seats more life. So some of them, they call it triple offset disc valve or butterfly valves. So what is the benefit each type of valve will give us? Let's look at first at the differential pressure across the valve. The higher differential pressure, the globe can actually withstand more higher pressure than the rest. Ball valve will give you a maximum flow because when it is open, it will be 100% as same as the gate valve, as if there is nothing in the line. If you look at the weight and the price, that is the butterfly valve are cheaper, especially if you go into a bigger size. Sometimes when you talking about 1 inch, 2 inch, 3, 4 inch maybe, we go to globe valve. When you go above that, let's say 12 inches, 24 inches and more, we go to butterfly because of the price difference. Let's look at another thing. If you have fluid which carries with it some solids like slurry, the type which we use is gate valve because when you open it, you actually release the gate from the body and there is a less erosion and damage to the valve. Cavitation, again, some of them prone to cavitation more than the rest. We will have other videos discuss cavitation, discussing the sizing by itself. So what we know now that some of them they have anti-cavitation or they less prone or suspect cavitation than others. Again, for noise, some of them they actually give you a good solution for a high noise application and they will reduce the noise to acceptable level. The size of the valve will dictate, as we said, if it's tiny valve, small valve, we may use the globe valve. Ball valves have bad reputation in controlling the flow and other stuff, but we use them because of the price and sometimes we need this specific type of valve for this application. So far we have seen two types of valves. One is a sliding stem and one is the quarter turn or rotary valve. Let's look at the actuator. The first type is the pneumatic diaphragm actuator. As you can see, there is a diaphragm in a case, and this diaphragm, you have the air goes from top, pushing the diaphragm down against spring. Now, the spring, as you can see here, it pushes the diaphragm up, mean it opens the valve. Here, it pushes the stem down and the plug down. That means the spring close the valve. That means the air will lift and open the valve. Here, the air will be closing our valve. One other thing we talk about is the failure mode of the valve. Failure meaning the air is lost, we don't have any air, the signal to the valve has been lost, the control system failed. So what going to happen to the valve? The spring will return it to its position. In this case, it will close the valve. In this case, it will open the valve. That's why we call this fail open this is fail close valve. Another type of actuator still using a pneumatic or air is a piston valve. The reason we use a piston because we can use a higher pressure than the diaphragm type. Here you can see we have a spring-loaded actuator. We call it single acting because you pressure it from one side against the spring. So the spring will not extend, will extract the stem from the valve. If you put the spring on this side, it will push the stem inside the valve. This is double acting actuator. You have one port for pushing it this way and another port to push it the other way. So this is double acting piston actuator. A vane actuator is another type of actuator which you have a flubber or a piece here. This piece, if you push air from this side, it moves to the other side and so on. Another type of actuator depends on electricity. Now, this is electric MOV or motor operated valve needs electric actuator. The electric actuator can be running from 110 to 20 or a different voltage, one single phase or three phase. Another type of actuator is a hydraulic actuator. As you can see, this valve is huge valve and the actuator is small actuator. The reason is that the hydraulic actuator can produce a lot of force. The pressure of oil is very high, so we can actually have a lot of force to lift all the gates here against the pressure of the line as well. So how control valve works? As you can see here, we have the valve. We need to operate the valve, a power source, air, electricity, or hydraulic. This will give us the power needed for your actuator. Now you need a signal to open the valve between 0 to 100%. This signal is, if it is coming from a PLC DCS, it's a 4 to 20 milliamps. If you have a pneumatic system, you will have 3 to 15 psi. You may have a different signals, but we're talking about 99% of the cases which you will find in the uh, process is 4 to 20 milliamps. The signal will dictate the valve opening percentage and the air or electricity or hydraulic, we will use it to open and close the valve. Now the signal, which is 4 to 20 milliamps coming from our DCS or PLC, will go to something called positioner. The positioner receives the air supply and receives the position of our stem and compare the position of your stem against the signal. And then it decides to move some air to the actuator to open it or close it to match the signal, meaning that the positioner will always try to change the position of the valve by varying the flow of air to the actuator or the pressure to the actuator to allow the valve to move to match the required opening by our PLC. What is I to B transducer? It receives the 4 to 20 milliamps from your PLC and it converted to 3 to 15 psi pressure. Now, this could be your signal to your positioner. The positioner again will have the air going to the actuator diaphragm to allow the valve to move to match the signal. We have more types of accessories. We talk about the positioner, the I to B, and then we have like the air filter regulator. The air going to our positioner, we need to regulate it, to filter it, to make sure it's clean and it's as a pressure which the positioner wants, 20 psi or maybe 50 psi or more or less. The other thing which is we need to identify for the valve is the connection type, the connection to your positioner. Is it half inch? It's quarter inch. what is the material of our positioner or component in the valve. If you have somewhere where you have an ammonia, we should not have any copper. So there is a different video. We'll talk about the corrosion in the atmosphere in your process, what to avoid, what to use, and what you should take care of. In the on-off application, we have a different type of position. We don't need a positioner. We need it to be 100% open or 100% closed. So we have two-way valves or three-way valves. Now the three-way valve, either to go, the air will go all the way to the pressure or to vent the pressure from the actuator to the atmosphere. Sometimes we have on top of our control valve a three-way which will be controlled by our SIS system to trip the valve, the control valve, and close it or open it in case of emergency. One of the other accessories we need is the limit switches. Limit switches will give a feedback from the valve position if it is fully open or fully closed. That means it is 0% or 100%. In another application, we need to know exactly what is the valve position, like between 0 and 100%, not 0 or 100%. In this case, we have a position transmitter feedback to our PLC or our DCS, which is normally 4 to 20 milliamps. In other videos, we will start to talk about valve selection, how we select our valve. Another video about the valve sizing. Cavitation will have a different video. Data sheets, how to fill a data sheets for a transmitter or a valve or something, but in our case, we will only talk about control valve. And finally, we will touch base on codes and the standard in control valve business. Thank you and see you in the new video. Please leave a comment, like, and share. If you have any suggestion, please let me know and we will discuss it together.